There's this bag that will contain 3 blue, 1 red, and 1 yellow counters. Can I write in the breakdown below also? So 3 are blue, 1 red, and Y will be your yellow counter. This person called Davina is going to choose 3 counters without replacement. They define S to be the sum of the number of blue and twice the number of red counters. Can we show that S is 3 will be this expression? To understand what they mean by the S, we may want to use a short example to understand. Let's say you have got 3 counters and you pick 1 blue, 1 red, and 1 yellow. Suppose these are the 3 counters picked. What do we know about the S value? S is trying to sum up the number of blue. So if you have 1 blue, we will have 1. It's trying to count twice the number of red. So you have 1 red will be 2 times 1. The number of red we must times 2. You got a yellow counter, it doesn't affect S because S is not summing up yellow at all. So in this small example, my S will be 3. It's counting how many blue and counting how many red you have but times 2. The better way to try to think about such a problem is to think of this S like it is a scoring system such that each blue that you have obtained, I think of it as every blue is 1 point. Every red that I take, I don't just count the red, I times 2. That means a red counter is counted as you get 2 points. But a yellow counter, nothing. So yellow is treated as no points. It may be easier to think of it this way to help you visualize what the S represents later on. Okay, so we can start the problem now. We start with that PS equals to 3. They want us to show that it's going to be this expression. I have written down for you one possible case of the BRY. Okay, so 1 blue, 1 red, 1 yellow, it will give me 3. There's another possible case that can give me 3, will be through 3 blue. If I take 3 blue, it will also give me that 3 points. So we can do the calculation. Each blue is 1 point, so 3 blue will be 3 points. To calculate, I need to know the total number. We are trying to do probability. The total number is Y plus 4 number of counters in all. So what's the chance of getting the BR rate? Maybe I write below would be better. We start with B. Blue, you have 3 counters. So getting a blue is 3 over Y plus 4. Getting a red, which is the second one, is 1 over Y plus 3. Yellow, you have Y of them. So Y over Y plus 2. Remember to permute. B, R, Y are all different letters. So when you permute, it will be 3 factorial. And then we continue to the 3 blue. Blue, you have 3. So 3 over Y plus 4. Three, 2, 1, and we reduce the denominators. We also will observe that the current denominators match what we need to show exactly. So I could combine them actually into one denominator. And at the top, this will be your 18y plus 6. Okay, and I can also show that we can factorize out that 6. Okay, part 2. It is given that that above expression is now going to be 7 over 20. It's equal. Can we solve for the value of y? Okay, note here for you first before I show you the solution. My y is the number of yellow counters. So y is an integer. Whenever you have an integer that is unknown, you should think about trying to use GC with a table. This is true for any chapter when your unknown is a whole number. Go for a graphing calculator with a table. If we equate these two together and you want to solve for the y, you help me flip to the next page first. I have the screenshots printed there. Okay, we talk about this, then we go back. So solving for this equation, the better approach will be move all to the left. You want to force the right-hand side to be 0. So that when you sketch this, you key in this equation, you are trying to look for, I set the whole equation to be 0 on the right-hand side. So we key this as a table. Put in the equation like a graph, but we go for a table, and you aim for a 0 on the right-hand side. 0 is easy to locate. But if you wanted to force and find 7 over 20, it's not easy. Okay, that's why you move everything to one side, look for the 0, and therefore my answer is x is 2. And my x is actually the unknown y that we're looking for. Okay, so this is how you use a table to try to locate the unknown looking for the 0. Okay, we flip back again. So suppose your y value is 2. Let's finish up the distribution. There will be an update in the numbers. So instead of 3, 1y, maybe I just write below, it's now 3 blue, 1 red, and 2 yellow, for which the total number is now 6. I have 6 counters. What are the other possible values of S? They won't tell you what values S can take. You have to calculate on your own. What's the minimum number of score? Can we get 0? If you want to get 0, means all the 3 counters must be yellow. Yellow is the only one that gives you 0. But there isn't 3 yellow, there's only 2. So the minimum possible number is actually 1. It's not possible to get 0 at all, will be 1. Only you have 2 yellow ones. Therefore, to get 1 is thought of as 1 blue and 2 yellow. Each blue is 1 point. So to get the blue, 3 out of 6. The 2 yellows, 2 over 5 and then 1/4. 3 factorial over 2 factorial. Blue, yellow, yellow. This is 3 over 20. And we continue the same for 2. Write down the cases that can give me 2. Each blue is 1 point, so this is 2 blue, 1 yellow. Or if you have a red, 1 red with 2 yellow. Blue, you have 3. So 3 over 6, 2 over 5. Before we go for yellow, yellow is 2. Permute for the different paths. Then you have 1 red, 2 yellow. And we permute. There's no need to go for 3 because the value for 3 is already known. So the next possible integer for us will be PS is 4. And how do we get the number 4? 4 must come from, must remember that for red, there's only 1 red. So if you take 1 red, the other 2 must be blue to add up to 4. And that is the biggest possible number. You can't get any bigger. 1 red and 2 blue. This will be your last case. Okay, red, 1, 6. Then blue and blue. Last thing to do is to form up the distribution table. We list down all possible values and outcome. So 1 to 4. Probabilities as well. Every time you have formed a distribution table, go for one final check. Because this is probability and you have listed all possible outcomes, you must check that the sum of probabilities must be 1. And again, it's because this is all possible outcomes. All possible outcomes must add up to